Hello, I'm Ron and welcome back to PopScicle, where I discuss pop culture, science, and everything in between. In this episode, I'll be talking about what pop culture usually gets wrong in terms of science and evolution. I hope this is going to be useful for those of you who are into science communication, particularly when you link it to pop culture, to literature, for example, and for those of you who are aspiring writers of science fiction texts. Hopefully, you'll be able to use this. I believe really that science fiction authors have the obligation to get the science right. Not necessarily stick to what science currently tells us, because then that wouldn't be fiction anymore, but to get the science right in terms of the foundation of what they'd like to say. And I believe that it's something that a lot of people get wrong, the fundamental understanding of both science and evolution. So I'd like to start with science first. One of the major assumptions about science is that it is a quest for absolute truth. We do science to get at the truth of the matter. To a certain extent, yes, we want to understand natural phenomena or how the world works through science, through experimentation, which is not even the only way to do science. That's the other misconception. Okay? But, science is not the quest for absolute truth, because it's important to point out that there is no such thing as absolute truth. Doubt is a hallmark of good science, meaning we always have to doubt if what we know now will forever be held true. Okay? When we do science, we are actually opening ourselves up to the possibility that what we know now can be disproven. That's what a hypothesis is. A hypothesis is, quote-unquote, an intelligent guess based on observation, sometimes based on experimentation, but there's always room for doubt. And there is no such thing as absolute truth in science. If that makes you uncomfortable, that is understandable. You might think, then what can I rely on? Is truth subjective, which can be quite problematic, especially in our society nowadays. Instead of thinking about it that way, think about it in the sense of science being a constant exploration, a constant satisfaction of the sense of wonder. Okay, constant search for answers. What we know now, and if they would stood the test of time, can be considered to be theories and even facts. Okay, but given new evidence, that can change, and that's what we, as scientists, or even people who just practice science in everyday life without being professional scientists, have to know. You have to be open to being proven wrong by new evidence as it comes out. What we know to be true in science is the best possible explanation based on current evidence. That's what it is. We do not say that this is the truth and will always be the truth. In fact, no self-respecting scientist would ever claim to know the truth and would say that what he or she knows cannot be changed. That's not how a scientist's mind should work. The other common misconception is with regard to what a hypothesis actually is and what we do with hypothesis. Commonly, people think that a hypothesis is supposed to be proven true, but that is not the case. We look at what we call the null or default hypothesis, which essentially assumes that there is no existing effect or no existing observed phenomenon. That's what we test, and we see if it can be disproven. If that is falsified or disproven, then we can entertain the alternative hypothesis. But we do not necessarily prove any one of those alternative hypotheses true. For example, when we test a drug, we start with and its effects on an organism's growth, for example. We start with the assumption that it does not have a significant effect. That's the null or default hypothesis. If we do see significant effects, and that's determined through statistical analysis typically, then we disprove or falsify that hypothesis. Okay? And then we are able to entertain the alternative hypothesis that there is a significant effect. Now, with regard to theories, a common misconception is that a theory, just because you call it a theory, means that it's not reliable. Okay? That we can't really put too much stock on it because it's just a theory. Bear in mind that a theory is an accumulation of hypotheses that have withstood the test of time. There's so much evidence available for theories. And theories explain natural phenomena. The natural phenomena themselves are the facts. Okay? For example, the fact that when you drop an object in the air, it will fall to the ground. What explains that is gravitational theory. The fact that organisms change over time, that populations change over time, that's evolution. It is a fact. It is something we readily observe. What explains it? What is the mechanism for evolution? That can be natural selection or genetic drift, the less known one. Those are the theories on the explanation for the facts. That's how science works. And we are very reliant on evidence. Again, we need this evidence to be able to have confidence in a particular fact or theory. If we don't have the evidence backing something up, we can't really rely on it. And science can't tell the public that this is something that you can rely on as something that is readily observable. Now, when it comes to natural phenomena, I say that science works on natural phenomena, but there are some things that are supernatural that doesn't necessarily mean that they can never be explained by science. Eventually, they can be. For now, they live outside the realm of science because they cannot be observed and they cannot be universally experienced. For example, some spiritual things. Those are not experienced by everyone. Paranormal activities like poltergeists and ghosts, these are also not universally experienced. But if ever anyone in the future is able to provide evidence for any of these, then they know they can no longer be considered supernatural and will be found within natural phenomena because science now has an explanation for them. One of the most important assumptions in science is that the universe is knowable by the human mind. We are capable of grasping that complexity. That's what actually makes Lovecraftian horror very, very scary and primal, because the assumption there is that there are some things out there in the universe that will make us mad or drive us insane if we try to understand them. But science gives us the comfort that that's not the way the universe works. And so when something is outside the realm of science currently, that just means that we currently don't have an explanation for that phenomenon. There are many other misconceptions about science. I believe I may have missed some, but I think those are some of the more important ones that if you have a basic understanding of them and you try to avoid these common misconceptions, you're on your way to providing a good scientific background to whatever story you'd like to tell. Now let's go to common misconceptions on evolution, of which there are a lot. You know, evolution is one of the most abused concepts in not only biology but in all of science. And that really adds to the misunderstanding on evolution, which is quite unfortunate. There's still a lot of people resisting evolution and what it says, even though scientists virtually consider it a fact of nature. What are some of the things that movies and books usually get wrong in evolution? One of them is that evolution is always natural selection. You may remember me saying just a while ago that natural selection, Darwinian evolution, survival of the fittest, quote unquote, is just one of several possible mechanisms or explanations for evolution. So when you say evolution, that does not necessarily mean natural selection. It does not necessarily mean that a particular characteristic was favored by nature over others. Genetic drift is the other major mechanism, and in fact, a lot of biologists believe that more evolutionary events are due to genetic drift than due to natural selection. This is completely random. It doesn't confer a survival or positive advantage to organisms. So just because you say that a population is evolving doesn't necessarily mean that it is evolving because there's a survival advantage of a particular trait like having gills or having a long neck or having claws or something like that. Okay, that's not, evolution is not equal to natural selection. Also, evolution is not equal to speciation. When you say that a population is evolving, that doesn't necessarily mean that that population is becoming a different species altogether. Speciation involves evolution, yes, but those two are not the same. For example, Homo sapiens is not currently speciating as far as we know. There's no new species out of Homo sapiens being produced. However, that doesn't mean that we are not evolving. Homo sapiens is under constant evolutionary pressure, and there are various groups like the Inuit tribes, the Buryat tribe in Siberia, the dairy farming communities in alpine communities of Europe, the Tibetans. These are examples of humans that are undergoing evolutionary change, sometimes within only a short amount of time. Because what you have to bear in mind when you talk about evolution is it's not necessarily a new species being produced. What defines evolution is that there's a significant change in the frequencies of traits in a population, such that, for instance, if at one time a particular trait is very, very low in frequency, meaning there's only a few individuals that have that trait, but after a while you notice that that trait is becoming represented in more and more and more individuals over time, then the frequency of that trait is increasing. That is evolution at work, most likely, particularly if it's conferring an advantage, and that's invoking natural selection already. When you talk about natural selection, that is when a particular trait increases the survivability and reproductive advantage of a particular individual over others, meaning it's more capable of reproducing and passing on its genes to the next generation. Now, I've mentioned population several times. A population is a group of individuals of the same species living together. It's important to bear in mind that evolution works on the population level, not on the individual level. Say you know a person that suddenly grows wings one day. Can you say that that individual evolved? No, an individual does not evolve. An individual's change over time is just developmental change, anatomical change within its lifetime. Evolution works on the population level, meaning it works on an entire group of individuals. You go back to what I said earlier about genetic change. For you to be able to say that the population is evolving, there has to be a change in the frequencies or the proportions of particular characteristics. And of course, you can't measure proportions of characteristics in a population if you're just looking at an individual, right? Now, one of the biggest misconceptions about evolution is that it is directed, it is preordained, it is programmed to go in a particular direction. A lot of the people who think that humans are the pinnacle of evolution believe that all animals are destined to become human-like, given enough time. That's directional evolution. Evolution does not work in that way. Evolution works with what is already there. If the genetic ingredients are there, then something is possible. For instance, if the world drowns in water because of global warming and polar ice caps melting, that doesn't necessarily mean that humans will spontaneously grow gills just to be able to survive. That's not how evolution works. If somehow the genes that prevent our embryological gills from forming are deactivated and do allow us to form gills, then a particular group of humans could potentially survive in water, but that's of course anatomically impractical and not feasible at all, despite actually having gills in our early embryological stages. There's a novel by Ursula Le Guin called The Word for World is Forest, where this is really shown. In a particular chapter in the book, there are some humans who believe that given enough time, the Asheans, who are ape-like, which are the alien species on the planet that they travel to, will eventually become human, given enough time. You'll see a lot of science fiction stories where just because there's a particular type of environmental pressure, like extreme temperature or pressure, the organism will evolve to become something in particular. That's not the case. It may happen, but only if the genetic components are already there and the developmental pathways necessary for the development of those traits are already in the organism. Of course, what introduces those genetic components are mutations, which are random and can result in a wide variety of things that can be pressured by the environment actually. It is true that the environment can influence genetics. Eventually, we might be able to explain it, especially if more and more people are able to experience and observe it. Now, one of the funnier but also more harmful misconceptions about evolution is that it's a completely linear process, particularly when you talk about one species becoming another. The common misunderstanding there lies in what goes on in the transition from one species to another. Some people think that there should be some hybrid. For example, in the ancestry of modern birds from their dinosaur ancestors? Should there have been a bird-like animal that still resembled a dinosaur? Not in the sense that you'd see a scary-looking dinosaur-bird hybrid. First of all, birds are dinosaurs, so it's useless to look at that missing link between a dinosaur and a bird. But also, there is no one single individual which is the last of its species, or one single individual which is the first of that new species. Okay? It's a gradation. It's gradual change. It's an accumulation of small changes. You can't point out that single individual that will be the start of a new species. That's how speciation works. And the problem with that is that a lot of people think that when you trace back the ancestry, it's going to be as simple as a human being evolved from a chimp, being evolved from another type of ape, being evolved from down the line, from reptiles, and then from fish. I mean, from an amphibian first, and then from a fish. That's not how it works. And the other common danger to that is people tend to believe in what is called devolution. I've seen a lot of cartoons and other materials that show this, that when, for example, a human is blasted with a devolution gun, you probably know what I'm talking about. The human will become eventually an insect, which we never came from in the first place. So you have to understand the lineages that gave rise to a particular species before you can invoke even something like that. But then there's no such thing as devolution, first and foremost. When a particular trait that already disappeared or has not appeared for a long time in a particular lineage suddenly appears again in some individuals, that is not those individuals devolving to a more primitive state. It's just a matter of the interplay between the environment and genetics. It may have been a particular gene activated, whereas before it has been inactive, and things like that. But it doesn't regress to an older species just because of that change. There's so much more to talk about. Actually, maybe I'll have another episode for more things that pop culture gets wrong in science and evolution in particular, because there's so much more to unpack. But for now, I think those are the major ones, and I hope that you can really benefit from this when you're making your new story or your speculative new monster for your adventures in D&D or your science fiction novels and short stories. Like I said, science fiction authors do have the responsibility to be, accurate at the very least in terms of the scientific grounding of their creations. For fantasy and horror creators, they don't necessarily have to be, because they work on the supernatural. They can explain the origin of a species through magic. But we can't afford to use magic as an explanation in science fiction, because we have scientific principles to do that for us. And so we have to get the science right? So if you liked what you saw and you would like to see more of these and other interesting things about pop culture, science, and the intersection between them, please don't forget to subscribe to PopScicle. I'll see you again soon.